There is a supervolcano in California that not too many people are aware of. There is also a potentially catastrophic earthquake fault system that is also largely unknown. The truly frightening thing is that these two geological threats could actually become linked in one cataclysmic disaster. This video will explore this possibility. Of course, the two main variables in how destructive volcanoes are relate to how violent the eruption is and how close people live to the volcano. The volcanic eruption of Mount St. Helens, which is located in a relatively sparsely populated area, is a good example of how a massive eruption can lead to relatively few deaths. Supervolcanoes are on a completely different scale. For example, in 1815, Mount Tambora in Indonesia killed at least 71,000 people, and its cloud of ash darkened the sky over large areas of the earth, causing the so-called year without a summer, and this caused famines in Europe and America. In addition to blocking out sunlight and changing the climate, supervolcanoes can also trigger tsunamis and giant earthquakes. The largest supervolcano in the United States is located at Yellowstone National Park. The above-ground part of this volcano was actually blown away in incredibly massive explosions. What remains is a large depression in the earth called a caldera. Underneath this caldera, there is still a very large chamber of molten lava which, at some time in the future, will probably trigger another eruption. The supervolcano in California had a massive eruption 760,000 years ago. It is now known as the Long Valley Caldera. It is located near Mammoth Mountain on the east side of the Sierra Nevada mountains. This map shows the debris field of the California eruption in comparison to the Yellowstone eruption. This chart gives you a comparison of the amount of material ejected from a sample of eruptions. As you can see, the Long Valley eruption ejected 580 cubic kilometers of material. This is equal to 360 cubic miles of material. That's 360 miles by 360 miles and 360 miles deep. That's an awful lot of material. Okay, now let's switch to discussing earthquakes and how a particular earthquake fault system in California may trigger another eruption at the Long Valley Caldera. In fact, I became interested in this potential disaster because of the July 2019 earthquake swarm near the town of Ridgecrest, where my daughter lives. As most people know, earthquakes are not uncommon in California. Major earthquakes have usually been associated with the San Andreas Fault or faults near the San Andreas Fault. For example, the 1906 San Francisco quake and fire destroyed large areas of the city. These photos show the type of earthquake damage that has occurred in the Los Angeles area. To put this in perspective, the Northridge 6.7 magnitude quake created a lot of damage and deaths. However, look at this diagram showing how a 6.7 quake is less than the smallest quake listed on this chart. Now notice the 2011 9.0 quake in Japan. This quake killed more than 18,000 people. This Google Earth image shows part of the geologic trough in the earth called the Walker Lane. You can see in this image how the quakes near Ridgecrest occurred essentially in a line that matches up with what is the path of Walker Lane. In this image, you can see the path of the San Andreas Fault and Walker Lane. And Walker Lane contains a system of many faults that theoretically could become linked. This would create a very long fault that would stretch all the way from the Gulf of California up to Pyramid Lake in Nevada. The Walker Lane trough along the Truckee River can be clearly seen in this image, which shows the upper part or the northern portion of Walker Lane. This image shows the middle part of Walker Lane and the site of the Long Valley Caldera supervolcano. Look closely at this diagram of essentially the same area, and you can see the spot where a dome is rising in the caldera as a result of magma that is pushing upward. This dome signals an increased likelihood of an eruption that could set off a major earthquake along the adjoining Walker Lane. This image shows a possible extension of Walker Lane down through the Salton Sea all the way to the Gulf of California. This image shows the location of earthquakes that have occurred in the Gulf of California that demonstrate a further extension of the fault. It's important to know that the longer the fault, the greater the magnitude of the quake that can occur. A fault system along Walker Lane, stretching from Pyramid Lake all the way down to the Gulf of California and through the Gulf of California, would be about 1,000 miles long. This theoretically could produce a mega 9.5 quake, or with the accompanying eruption of the Long Valley caldera, an even greater release of energy could occur. In fact, a 9.5 magnitude quake did occur in 1960 in Chile along a fault that was almost 1,000 miles long. This table was created to illustrate some very basic concepts about the occurrence of earthquakes. To do this, the table used worldwide quake frequencies and the calculated corresponding risks. It does not show frequency or risk information for a particular area, however. For example, the quake frequency and risk for Ridgecrest would be much higher than a city like Stockton in the Central Valley of California, where there are very few faults. So read the table like this. A magnitude 5 quake was given an arbitrary risk factor of 1. Since worldwide there are 1,500 magnitude 5 quakes every year, the risk factor for a category 5 earthquake is 1 times 1,500, or 1,500. A magnitude 6 quake is not greater by a factor of 1. The factor is actually 33. So because there are 150 magnitude 6 quakes per year, 150 is multiplied by 33, thus giving a risk factor of 4,950. If you study the chart, you can see that the worldwide risk for a magnitude 10 quake is relatively low. This is because even though the energy released would be about 39 million times greater than a magnitude 5, the likelihood of it happening is very low in any given year. In fact, the greatest risk is actually from a magnitude 7 quake. These calculations may reduce your anxiety about the big one happening, but remember, calculations on paper won't prevent the worst from happening at any time. The following photos show some additional evidence of volcanic activity along Walker Lane.